Hi, how's it going? So I'm going to go through exercise 5C, question 3. Okay, that's one of the questions I asked you to do. So I'm going to read through it. It says a particle of mass 0.5 kilograms is sliding down a rough slope angled at 15 degrees to the horizontal. Acceleration of the particle is 0.25. Calculate the coefficient of friction between the particle and the slope. Okay, so right, what I'm going to do is a bit difficult because I'm holding the phone at the same time. I'm going to have a go. There we go, that's the slope. Ooh, it doesn't quite look like 15 degrees, is it? But never mind. So there's the object there. Right, so the weight, I'm going to have going all the way downwards like that. Okay, and it said it was 0.5 kilograms, so I could put 0.5 G like that. Now, watch carefully, because the textbook never does this. I mentioned it to you a couple of times last week, but I really don't want you to forget this point. I put in this here called the weight triangle, and that angle there is 15 degrees. The reason for that is because you'll need to resolve parallel to the slope and perpendicular to the slope as well. And in doing this triangle, it breaks the weight component, which is vertical, into the parallel and perpendicular components. Okay, so that's really important. Okay, right. Next, there will be a normal reaction, which is there at 90 degrees to the direction of motion. It says it's angle 15 degrees. Part is sliding down a slope. That's what I was looking for, to see which direction it's in, because that's all important. So acceleration is that way. So that means that the frictional force must be the opposite direction, which is up the slope that way. Okay, and just read the question again. So notice just how many times I'm doing this. I'm reading the question just to make sure I'm not missing any bits out. Okay, that's the question. I think I'm ready to go now. Calculate the coefficient of friction between the particle and the slope. Right, so what I'm going to do is I'm going to resolve perpendicular to slope, and I'm going to have R as perpendicular, and equal and opposite it must be this bit, which is the weight component perpendicular. So the weight is 0.5 G, and this bit is adjacent to 15 degrees, so it's going to be cosine 15 degrees. So 0.5 G cosine 15 degrees, that's it, simple. Parallel to the slope comes next. And parallel to the slope, positive first of all, down the slope is 0.5 G. And of course this one's going to be sine, because it's opposite 15 degrees. So sine 15 degrees. Then opposing that is going to be the frictional force. So that's the only forces acting parallel to the slope. Because it's moving, that's equal to the mass, 0.5 times by the acceleration, so 0.5a, like that. Okay, I can then rearrange that and make F the subject. Okay. Oh, look at that! I told the acceleration is 0.25 as well, so I'm going to do that as well. I'll tell you what, I'll put it in now. 0.5 G sine 15 degrees subtract F is equal to 0.25, it's a quarter, isn't it? Times by half, it's 1/8. 1/8. Okay, like that. So make F the subject. F is equal to 0.5 G sine 15 degrees, subtract 1/8. Okay, and then I can put them together using F equals mu R. So I've got 0.5 G sine 15 degrees subtract 1/8 is equal to mu times R. Well, if I rearrange that, I'm going to have mu is equal to F over R. So mu is equal to friction force there over R, which was 0.5 G cosine 15 degrees. And I just need to work out what that is. So here comes my calculator. So 0.5 times 9.8, I know what that is, but I'll just type it anyway, times sine 15 degrees equals, subtract 0.125 equals, okay, so divide by half, times by 2, divide by 9.8, okay, divide by cosine 15 degrees equals, and 2.42. Sorry, 0.2415, blah, 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 blah. Significant figures, that will do. 0.24. Okay, just check your calculus in radians mode, as is mine, before you do it. Hope you found that helpful. Okay, bye-bye.